This video looks at the new Mplab Ice 4, Microchip's fastest and most feature-rich in-circuit emulator and production programmer. The Mplab Ice 4 supports all Microchip microcontrollers, including PIC, DSPIC, AVR and SAM devices, and works with the many varied on-chip debugging interfaces these devices implement. Utilizing the built-in emulation circuitry of these target devices, the Ice 4 can execute code with true electrical and timing characteristics, can conditionally halt execution, and upload program flow and data memory for display in the Mplab X IDE. Getting started with the Ice 4 is easy. Connect the emulator to your host computer with the supplied USB cable, connect the power supply, then run the Mplab X IDE. Select the Manage Network Tools menu item to change the default network configuration. It will initially be set to USB. For the selected tool, choose Ethernet using DHCP to connect using an Ethernet cable and have IP addresses automatically assigned. Wi-Fi access point to have the Ice 4 create a wireless network that your host PC can connect to. Ethernet static IP to connect using an Ethernet cable where the connection settings have been manually specified. Or Wi-Fi station mode to have your Ice 4 connect to the specified Wi-Fi router shared with your host computer. These alternate options allow the Ice 4 to be physically separated from the host computer and also permit it to be used from virtual environments, such as a Docker container used in CI/CD pipelines. Update the connection type with your selection, disconnect the USB cable, and the Ice 4 will reboot using the new network interface. Click the Scan button to identify it and its new settings. The best debugging performance is obtained when the Ice 4 is connected to target hardware using the dedicated 40-pin ribbon cable. Matching 40-pin connectors are provided to include in your own hardware design. When connecting to older hardware or Microchip development boards, adapter boards included with the emulator accommodate the wide range of devices and debugging protocols available. Choose the JTAG adapter board or Cortex-M trace adapter board, usable with selected SAM MCUs, the PIC32 instruction trace adapter board, usable with PIC32M devices, or the ICSP adapter board, usable with selected 8 and 16-bit PIC devices. This board can also be used with a number of 6 and 10-pin ICSP adapter boards for AVR MCUs, supporting JTAG and other programming and debugging interfaces. To use the Ice 4 as a programming or debugging tool, simply select the Ice 4 tool in the Select Device page when creating a new project. For existing projects, swap to using the Ice 4 from the Project Configuration category in the Project Properties. Once selected, confirm the settings in the Ice 4 category of the Project Properties. Most settings can typically be left in their default state, but as a minimum, you should indicate if the Ice 4 must supply power to the target board and ensure that the communication interface is correct for your hardware. The controls to run and debug programs will be familiar to those who have used other Microchip tools. For example, you can simply click the Debug Project button to have your project built, downloaded onto the target board, and then executed. The Ice 4 supports many debugging features. These include virtual COM ports, which provide a bridge between the target UART and the USB interface, and which can, if required, be accessed from a virtual container in a CI/CD pipeline. Data gateway interfaces, for low-level transport of data from many target communication interfaces, such as SPI or I2C, or other interfaces such as timestamp and power. Data capture and runtime watches, which are used by IDE plugins, such as the Mplab Data Visualizer, to stream values written to memory, and PC sampling and profiling, which allow the Mplab X IDE to display the amount of time spent in each function. You should always check the Mplab Ice 4 in-circuit emulators User's Guide to determine which devices and adapter boards are supported by each of these features, and if the feature will only operate when connection to the host is via USB. The Ice 4 is being released with a number of advanced debugging features, such as a power monitor, which uses two independent current sense channels to measure the voltage present and current being drawn by a board or microcontroller. Using the data visualizer, sampled voltage and current values are transmitted through the data gateway power interface. The measurements can be interpreted as power and plotted using the data visualizer's controls. For AVR and SAM devices, PC data can additionally be captured, correlating program code and the power it consumes. Another useful debugging feature is Program Trace. Trace facilities can be enabled from the Ice 4 category under Trace and Profiling. Only the types of trace relevant for your selected target device will be shown, along with other options. The Ice 4 supports Instruction Trace, where a non-intrusive hardware trace module on the target device captures every instruction executed. This record of program flow is streamed to your host computer via the Ice 4 for viewing in the IDE once the program has been halted. Support is also offered for Instrumented Trace, where execution of special statements that you embed into your project source code transmit data to the Ice 4 when they are executed. This form of trace generates significantly less data, which makes it easier to identify and focus on areas of your program that are of particular concern. For example, trace and log macros can be added for many 8 and 16-bit devices to instrument your code at those locations where you need to track program execution and examine memory. The data can be observed in the Trace window once the program has been halted. For SAM devices, printf-style debugging statements can be added to utilize the device's instrumentation trace macro cell block, which implements timestamp functionality. The results of expressions are displayed in the IDE as the program executes. The new Mplab Ice 4 is a capable development tool. Not only a production programmer, it debugs embedded processors at maximum speed through a variety of wired and wireless host communication interfaces. Delivering faster programming times and useful debug information, it helps you get the most challenging of projects into production sooner.